Hello, welcome to Loughborough University, the Natural Sciences course talk today. I am Paul Roach, I'm the Director of the Natural Sciences course here at Loughborough, and today in this talk I want to introduce you to what natural sciences really is and how we wanted to evolve this at Loughborough University, and really kind of put across to you what it is about our course that's particularly relevant in terms of the current climate today. So when I designed the course a few years ago, I really wanted to bring in aspects of what students really quite like to do in individual disciplines, but also across different disciplines, and really get students to be excited about what their interests are. So I wanted students to really follow their passions. When I did my studies, I really was told by my parents to kind of follow and be ambitious in what you want to do. And a lot of that is academic based, but there's an awful lot of that that's not academic based, and it's kind of supplementary to my studies. And I wanted students to kind of really feel that they can look outside of their academic studies and be who they are and follow their passions, whether they're in a module or basically within cohorts. So I wanted to get that across within the flair of the course. So Loughborough University is the largest single site campus in the UK. So here's a map of it. Just north of this, just off the top of the screen here, we have the M1. So we're very, very closely linked to the regional motorway system. We have over 5,500 students living in halls on campus, and this number is a little bit smaller than it should be. We've now got new halls of residence opened up, which is going to increase this number slightly. So that's kind of a phased opening of this new hall of residence. We have one of the largest independently owned student unions on campus. So being quite a large campus, we have an awful lot of students that are living on or close to campus. So it's a very, very student feel. It's the Loughborough University, Loughborough family logo that we use quite often really kind of comes to the fore when we talk about how the feel is of the campus. I wish you could come today to have a look around and kind of enjoy the atmosphere around the campus. If you did come, you'd find that it is quite a long campus. So to take a walk from one side of the campus, so down here at the bottom where we've got the Olympic swimming pool, which is on the southern edge of the campus, and to walk from there all the way to the top side of campus will take you about 15-20 minutes. But there is a shuttle bus that runs through campus, so visitors and students alike can jump on and off the shuttle bus, which runs every 5 minutes through term time and just a little bit longer on weekends and outside term time, so it kind of keeps you connected. The shuttle bus also does come out of campus all the way through the middle of town and to the train station. So there's the train station Loughborough, which is directly linked to Leicester and to Nottingham on that line. So we're only about an hour and a half away from London, for instance, as a direct train line. So we're very, very closely connected. Now, walking out of campus on the south side, you can get to town within, again, about another 15 minutes. So students can come onto campus and they can live on campus for the whole time without ever coming off campus if they wish. I wouldn't advise it, but there are art centres, theatres, banks, healthcare services, dentists and so on campus. But Loughborough is a small market town, so we have quite a lot of different shops, restaurants, bars, facilities, leisure activities and things in Loughborough as a market town. But again, we're only about a 10-minute train journey into the big cities like Nottingham and Leicester down the road. So just to give you a look-see at one of our halls of residence, so they all have kind of the central facilities, there's like the common room, the laundry facilities, bike storage. We are kind of enthusiastic to promote kind of the connectivity between students and make students feel at home at Loughborough. The catered halls have, as you see on the left here, places where the students can get food, and if you were here on a visit day, then we would take you to sample the food at our halls residence restaurants. So Loughborough University is well known for many things, and I'm sure you've heard in the media lots of things about our reputation in terms of the University of the Year, where we're ranked in the league tables in terms of the Guardian League table or the Complete University Guide. We do very well in all these tables, so I'm not going to sit here and kind of read off this list. But what I will say is that we are known very well for what we offer, both in terms of the academic standing, the entrepreneurship, the sporting facilities, the dedication of our lecturers to provide a quality teaching service to students, and also the kind of entrepreneurial aspect as well. So we do an awful lot of things for our students, and a lot of our staff also live very, very close to campus. So it is very much of a kind of family vibe to the campus. Now, having said all of that, Loughborough University is very well known for its sports. So we were the official preparation camp headquarters for the Team GB in Japan for the Olympic 2012. We are recognised as a kind of sporting excellence university, and our facilities are absolutely second to none. Having said that, I am not very sporty myself. The closest I come to being sporty is that I live quite close to Adam Peaty's parents. But for me, personally, the atmosphere of Loughborough is really something that's quite different to all the universities that I've worked at. So when you drive through campus, when you see other students kind of running around, you can get involved with lots of different sporting activities, and these range from running, from swimming, from all different types of different levels of sporting activities, through from kind of professional cricket down to or across to Quidditch. So people just enjoy activities outside. So being a non-sporty person myself, I do quite like to see all the students enjoying themselves, and I occasionally get involved in that in some activities that are on. So it is really up to you whether you want to be involved. But we are very well known for the sporting excellence. But it's not a push for you to get involved if it's not really your thing. So why study natural sciences at Loughborough? So we're kind of building on established strengths across our disciplines. So we offer a massive strength in physical sciences. We're well known across the UK and worldwide for regenerative medicine and our teaching and research into health. So all of the aspects of natural sciences build on this framework in terms of the world-class research and how that research informs the teaching directly. So we're known in terms of the teaching excellence frameworks. We have a gold standard, that's the highest standard in the teaching excellence framework. And building on this and helping to kind of pull this all together, we now have absolutely brand new facilities to kind of bring the pool of expertise together under one roof. So again, if you were here today, you would see this new facility. So this is the STEM lab facility. The STEM lab is a part of the university's drive to kind of bring the different disciplines together under one roof. So in natural sciences, you would select out 2 specialist pathways, and alongside that, in your first year, you would do a kind of a core skills element, and these are really kind of transferable skills, allowing you to develop your personal professionalism, which can be applied throughout your career at the university, throughout your career outside of university, if you wanted to apply for different part-time jobs, or you wanted to expand your professional network. All of these kind of core skills will contribute to that, so that's why that's in the first year. And we really do build on that in the later years, but the later years you will then go and specialise and focus in on the subject areas, the subject pathways. So in year 2 you'll just do the kind of specialist pathways that you've chosen, and in year 3 you can then start to really specialise. So if you've chosen 2 fundamental pathways in year 1 alongside core skills, in year 2 you would continue on those two pathways. Then in year 3 we can either give the option to remain on both those pathways, or you might think, well, actually I prefer this pathway and want to only focus that on that in the 3rd year. And if you did 4 years, you would then just do that one pathway in that 4th year. So the course is housed within the School of Science, and importantly, very importantly, it's taught by experts in the individual schools and departments of the elements that you choose. So if you choose to do chemistry and bioscience, you will be taught by experts in chemistry, and then biosciences from that other department. Likewise, materials, we have a fantastic materials department, and also geography. So we use the expertise, the facilities that we've got in each of those expert areas and build on that. So we're kind of bring that together and build on that. So the STEM lab facilities was part of a £65 million refurbishment over the last 2 or 3 years, and the STEM lab itself, we were very lucky to obtain the funding for this, not just for the nice shiny building and how that layout of the building allows us to deliver teaching in a very unique way, but also that a lot of the tools, the techniques, the instruments we've got inside that building are brand new as well. So a student that's starting with us will be trained on some equipment that is state of the art, which will then flow through. If they got a job afterwards, then they wouldn't need retraining on an instrument, for instance, giving chemistry an example. So the ambition really for the course is to really get students in and really get them to follow what they want to do. And in this, I'm really trying to build this knowledge base. There are lots of challenges worldwide, particularly now it's probably relevant, but there are major challenges in health, in ageing, in different materials development and how these materials are used, in recycling, in environmental concerns, in different technologies. There are all these different issues, and they cannot be addressed by a person that's studying in a single discipline. So up till now, up till probably 3, 4, 5 years ago, a lot of these research scientists in very distinct fields were working with each other in collaboration. So we'll bring physicists in with chemists, with material scientists, and but the more and more, certainly over the last decade, we've seen a really crossover. So now people that are really able to understand the different disciplines and communicate across them are where the kind of niche areas and where the kind of excellence is really coming through. So natural sciences is really about allowing people to follow their interests in a subject area which may kind of actually span across multiple different disciplines, and that's what we try to allow, but also really try to propagate that through the course. So to give you some examples, if we wanted to design a new hip implant, so on the bottom left here we have a hip implant. Now this may well have been the same sort of hip implant for the last 5 or 6 years. The material that's been developed for these use has basically progressed over the last 15-20 years to allow us to have a material that kind of works mostly. The coatings around that are kind of changing and becoming better. But who would make this hip implant? Who actually designed it? How did it come to fruition? So clearly, material scientists need to be in there. They need to be working with biologists, maybe some chemists in there to look at the degradation properties of hip implants and how they actually interact with the biology from a chemical perspective. Who designs it? Who actually looks at the shape, the geometry of that hip to make sure that it's suitable for its fit purpose? A synthetic hip, like this metal hip here, isn't exactly the same shape as a normal natural hip. So there would be mathematical modelers, designers, physicists involved in the process as well. So this problem is a problem that's very well known to probably many of us in the audience, but it is a problem that's really challenging to work on in isolation from many other fields. So actually having a chemist that can talk to a material scientist that can actually understand what a biologist is saying in their own language is really, really, really useful. And that's obviously that's my area of expertise. So if we move on from this metal implant and look at actually what bone looks like, there are some types of treatments where we want to actually make and renew bone. So bone is actually quite a unique tissue in that it can start to regenerate itself. There are cells in there that allow it to regenerate, but we probably need some sort of scaffold to help the cells along to give them some sort of structure to grow onto. So if we're bringing this picture here in the middle, this natural bone, this is a microscope image of what natural bone looks like. So these pores within this structure allow the cells to reside and then to proliferate, and then to basically the bone cells will mineralise around to give this mineral structure. Now we can make this type of material in a synthetic bone. So this might be a polymeric bone substance, it might be a ceramic bone substance, and this is one avenue of kind of the sciences helping medicine in this way. So I've been involved in some research where we've wanted to actually make a bone plug. So this bone plug here on the right was developed, and it was quite rather than being hard like bone, it had a kind of a spongy and quite a tacky feel to it. And this is because talking to surgeons, they wanted to be able to fix a bone with a material that could be squeezed into a defect, a hole, and then basically spring back to fill the gap which will be quite quick to implant, but they needed it to be conducive for the cells within that environment, the biological environment, to actually take hold and then form the natural bone eventually later on. So that's some work that we did some years ago. So now if I kind of bring you back to something that might seem a little bit odd, the link between toothpaste and shark teeth. So only a chemist would tell you that shark teeth are very, very, very hard because of the chemical nature of that mineral that they're made from. So in that mineral that they're made from, it's kind of a little bit like bone, but they've actually got a fluoride integrated into the structure. And that fluoride does two things for us as humans. One, you'll infer from what I've already said that the fluoride helps to strengthen the teeth. But we can also put fluoride in toothpaste or mouthwash. That helps to strengthen our teeth, but it also helps to starve off any bacterial infections. It actually stops any infections in the mouth. So including fluoride into drinking water, into toothpaste and mouthwash has really helped us to progress in that way. But we couldn't have done that from a chemistry perspective. We needed to understand materials before that then flowed over into chemistry of materials and then flowed over into kind of use in a clinical setting. So it's quite an elongated process there because we weren't talking together at that point. So it was quite an information flow. It was very, very, very elongated. So I thought it was quite useful with this part of the talk to talk a little bit about me as the director, because I designed the course. I thought it was useful to tell you a little bit about my background and how I've inferred some things into the course. So I started life as a kind of a synthetic chemistry student many moons ago now, but I was making molecules in the lab, and then I went in to do a PhD in materials chemistry where I took some molecules and then made materials from them. But I wanted to understand the interaction of those materials with their outer environment. So here are some porous materials or some structured materials which, if you put water on top of them, the water can roll around or it can impregnate into the structure depending on the surface chemistry. So then I went into a physics group. So I was knee deep in physics within a few weeks, but I was looking at sensor technologies and helping to design different sensors. So that's my finger in the image here with a very small stamp-sized sensor on there. And this sensor is very, very, very sensitive to pick up changes on its surface. And the sensitizing agent on the surface is the chemical or biochemical agent that attaches there. So we can start to use these types of sensors to detect very, very, very small amounts of molecules in solutions, in the gas phase, in air. So things like the virus currently, things like anthrax detection, the spore detection, different biological samples within blood. That's what these sensors could be used for. But again, my thread of chemistry, surface analysis, and so on took me through to that angle there. And when I was finishing up that post, I was really wanting to kind of get back into the kind of materials chemistry and how materials helped to direct what biology does. So biology, cells in our body will do what they're told to do as they develop. But when we take cells out of the body into the lab, into the laboratory, then they lose their signals, so that they don't really know what they do. So they'll just basically do what they think they should do. They'll grow and move around, but there's no kind of guided control. So I was using in this project surfaces again to structure a signal to the cells to actually get them to do something that I wanted them to do. So then I kind of now put that all together. So I use chemistry of surfaces, chemistry of materials, structures of surfaces at the nano scale and at the micro scale to really direct cells, and I specifically work mostly on neuronal cells. So we make living functional nerve circuits using living nerve cells. And this work has been funded by the government for looking at the development of different disease states such as Parkinson's, Huntington's, Alzheimer's, and we've also had some funding from Parkinson's Research UK. So I've told you about the bone plug already. When I started as a synthetic organic chemist many moons ago, I did never think that I'd be working on brain-on-chip devices, and I certainly didn't think that I would be getting into an operating theatre. But now, more often than not, I'm phoned up by surgeons to ask me to come into a surgical procedure to look at what they're doing and try and help them to develop something better. So one example of this is a knee device where the surgeons were looking to transplant some stem cells to regenerate the cartilage in knee for instance for osteoarthritis. And the method they were using to develop these stem cell therapies was kind of working a little bit, but it wasn't as beneficial as they thought it might be. So they invited me in to look at the processes, the materials that they were using to kind of capture these cells and to keep them in that niche environment. So again, I can talk and communicate with surgeons from their perspective, but also get across the chemistry, the physics, the materials characteristics that are needed to try and help solve them problems. So you would think that getting into surgery would be where my passion lies, and yes, I think that you're probably quite right. But also, what gets me out of bed in the morning is actually working with people that have diseases. So the Friends of Parkinson's is a Facebook group set up by people I've worked with, clearly with the brain on chip devices, and these are patients suffering from Parkinson's disease where there is no cure. So this is an emerging disease. There are some treatments that are not very effective. There are currently no cures, and this is the same for many of the neurosystem, the central nervous system diseases. So I hope that my research can really try and tackle some of these problems to really give these people some hope that in the future that there may well be a therapeutic or a way forward to help them and their families from this disease. So let's bring you back to the course. As I said earlier, in your first year in Part A, you'll choose 2 pathways alongside the core skills, and you'll move into Part B and specialise only on those two kind of pathways that you've picked out in year 1. So those pathways are a combination of chemistry, physics, maths, biosciences, geography, and materials. And you'll see on the website the kind of combinations that you can flow through those. So there are a couple of combinations that we don't offer, and that's because we're really key in our timetabling to really offer what we can deliver, rather than offer you a whole wide selection of different modules that you might choose, but then finally have clashes with them. So we really direct you to the ones that we've kind of offered on the website, so you can really see really clearly. And the most common ones that I picked up are chemistry and physics, or physics and maths, chemistry, biosciences, bioscience and materials, for instance. So there are many options out there, so please do look at our website for the different kind of combinations of pathways that are offered. Now after you finish your second year, you have a decision whether you want to go on to a placement year, which is a very optional, so not all students do this. It is a very competitive situation, but we do have an awful lot of processes to help you apply for these placement years, and this is a placement away, maybe abroad. A lot of our students go into industry, and that really is kind of your first job, if you will. So you either go through your degree, finish with your degree, and then go into your first job, or you can get some help, support, and actually experience the world of industry as you go through. Now, the pictured here is Carlin. So he did 2 years in chemistry, and then went into a placement in a company down south. And we do put students out into industry. A lot of the companies come back to us year on year. They know the quality of our students. We do get a lot of interest from many industries, and I'll give you a bit of an insight into kind of the breadth of that later on. But after you go on to, when you come back from placement, or if you just move from your second year into your third year, in your third year in Part C, you'll now have the decision to choose either one of those pathways, or keep spreading out onto both of them, and that's really down to you, and you can choose and decide that as you move through the years. So it's not a decision you have to make early. I've kept the decisions and the course structure as fluid as much as I can for as long as I can, to really kind of let you feel how we develop through your career with us. So after your Part C, again, you can have this optional placement year then, if you are going on to a Part D, or you might leave us after Part C. So if you're moving into a Part D, which is an MSci for natural sciences, that's now a highly specialised year, so that will be specialised in only one of the pathways. So let's take an example where you did chemistry and biosciences in year 1 alongside core skills. You have the option then to do those 2 pathways in Part B. So you just do chemistry and biosciences in Part B. And let's take the example where you just move straight into Part C. So now you'd either do just chemistry or just biology, or you'd actually do both of those pathways. And now if you then went into Part D, now you will just specialise in either chemistry or biosciences in that aspect. So we're not just a dual honours degree. Natural sciences is much more than that. It's about bringing the students together to talk about the differences between, the interface between all of these different disciplines. So let's take the example of a student that's doing chemistry and biosciences with us. They might want to get into the physics lab. They might want to look at some aspects of materials or geography and so on. So we allow students to experience the breadth of the course, albeit that they're focusing on certain aspects within the course, and they might not ever be tested on geography, but they might have an underlying passion for looking at climate change or so on and so forth. So that's part of the development, and we really kind of support students to really follow what their interests are. So it's a very distinctive course, and hopefully I've got that across. It's quite modular, so you do choose which modules you take, which pathways you choose, and we've tried to pair up the pathways from one year to the next, but also kind of horizontally across the different pathways. So for instance, if you were doing biosciences and materials, you'd find that there's a regenerative medicine aspect in biosciences, and there's also a biomaterials and nanotechnology class in the materials section. So there's quite a lot of overlap, and I've tried to do that to really allow this kind of cross-disciplinary nature to really kind of take hold. And it really does build on your interests. So you might see yourself, like some of these students in the pictures here, being in a chemistry lab, getting into a physics lab, kind of building on the core skills. You might have interests of being in a biology lab, or looking at some of the physics equipment that we've got, and getting your hands on that aspect. And certainly in your projects, which I'll talk about in a second, you might find yourself in the field, in the geography course. But this is all academic, this is all inside the course, and as I said earlier, there are lots of things that are outside the course. So we do offer what I like to call wet tutorials. So students that are not in a particular pathway, for instance, they might not be doing physics, they might not have done physics since GCSE, but they might have an interest in that. Why not bring them into the lab alongside other students and help them to experience a little bit of that, to try and strengthen their knowledge, maybe in terms of kind of computer programming or 3D printing or so on. It might be that there might be other extracurricular activities that they want to do. So students in the past have come to me and said, I'm really interested in hobbyist astronomy, and we have expertise on campus. So I knocked on some doors, and we had an evening seminar, very informal, brought the student cohort together, some staff came along, it was great. We had a seminar from a physicist who teaches astronomy in a physics degree, and then the plan was to go to the observatory that evening. So we have that on campus as well. So because there are expertise on campus doesn't mean that the doors are closed if it's not in your course. I want to open them doors and really figure out what your passions are and help you to follow that through the course. So in your third year, and certainly if you do your fourth year as well with us, the projects are a big driver for your interests and also for your CV in terms of your springboarding to different jobs. So I wanted to kind of use this slide here to just give you some examples, again across the different disciplines that you could kind of go into. So these are all based on current research activities within Loughborough. So Brain on Chip is obviously my aspect. So I have students from chemistry doing this, and they know very little about growing cells in the lab, but we teach them how to culture cells in the lab, how to monitor them, how to do microscopy, how to make some images like these little mini brains at the top in the middle here. We teach them how to do some microfabrication or kind of simple electronics. So that's taking a chemist or a natural scientist out of the box in which they might kind of feel them. And usually students will really kind of open up and really like this kind of interdisciplinary aspect. Students might choose to do a project on kind of synthesis of functional materials, and the function here might be vastly different from depending on one research group to the next. So the function might be magnetic, it might be that they're biodegradable, it might be 3D printable. There are many different types of functions that we can use, and they're used for different things. It might be that these materials are used for novel sensing. It might be parts of a new device that's made up. So we have lots of research activity in terms of different types of sensing. And again, this sensing might be for health diagnostics. It might be for viruses. Might be for food testing. Could be for climate or environmental changes. Again, the application of these is again built on our existing research strengths across our pitch. We do quite a lot of work in molecular electronics, molecular design, and then again going into kind of sustainable plastics. So again, we're looking at the chemistry, materials, the physics underpins all of these aspects, going into geography, bioscience, and so on. So hopefully these examples give you an idea again of the breadth and the depth that you could experience at Loughborough. To get into more detail of the course, so each year of the course is divided into 120 credits, and these are broken out into modules. Each module accounts for between 10 and 20 credits. The project modules are larger, they're between 40 and 80 credits depending on which year you're in. So what does this actually mean? So a 20 credit module is about 200 hours of effort. Now that does not mean that you'll have 200 hours of a lecturer standing in front of you talking at you for 200 hours. That means that you've got about 40 hours of contact time and about 160 hours of individual study time, independent learning time. So that's guided learning. We might give you some reading to do, we might tell you to go and do some sample sheets, revision for lectures, revision for workshops and so on. But bear in mind that these 40 content hours doesn't mean that that's 40 hours bye, see you later, good luck for the exam. It's 40 hours of delivery, but often we'll put on extra sessions if students are needing some extra help. Then we offer an open door policy for all of our students, and a lot of the feedback that we get is very supportive because we are here to support the students, and they do come and interact with us. We know them personally. I'm not Dr. Roach, I'm Paul, and a lot of my colleagues are the same. So we work on an individual basis, and we do know our students, and we kind of know their personalities, we know what their strengths are, what their weaknesses are, and we do look at that to try and really help them in any way that we can. So the lecture slots that we might have within these 40 hours are built up between 1 and 2 hour sessions. If you do a 2 hour session, there's usually a small break in the middle. And we also have tutorials, seminars, workshops, and individual sessions, which are kind of smaller group sessions to really allow students to interact with us. We do have an awful lot of online learning as well, particularly in these times, but normally, so all of our lectures are captured so students can log in remotely afterwards and watch again our lectures rather than just looking at the notes. There's online tutorial material, there are online quizzes, so students can log into a portal and kind of be helped in their independent learning. But we are here on the end of an email, or if they're in the corridor, they can just nip in and say hi and ask them questions. So, okay. So the entry requirements for our natural sciences is AAB for the BSc and AAA for the MSci route, and I've shown the equivalents here across the IB and BTEC levels and so on. So some of the questions that we normally get asked: when are the exams? The exams are at the end of each semester usually. There are not just exams, there are other types of assessments. So we have different types of coursework, multiple choice questions, small answer, long answer, essay type questions, essays, presentation skills. So we build up on all of these, and we like to use the course to spread these out. So some students will really like exams, some students will hate exams but really like to do lots of essays and coursework and reports. So we give you the skills that you will need in your future career to cover all of these, and most of those are done in the first semester in natural sciences and the core skills. So I run a science communication module where we really get to grips with different types of pitch for presentations and so on and so forth. So when would you like feedback is another question. So we like to give feedback as we go through. So you don't just do a piece of coursework and then get feedback and think, well, actually I could have done better if I'd done this. We give you feedback on the fly. We do give you the formal feedback directly after a piece of work is submitted, but we like to give you feedback that's direct. So if we're doing a workshop, we'll probably tell you this is a better way to do this, or you can think about doing this. So again, we discuss with you. It's not just a one-way delivery. We really like to discuss with you. The assessments are both formative and summative, which means that we give you an assessment probably throughout the length of the module, and that gives you a little bit of feedback on exactly what you have done right and what you could do better, and that will help you in terms of your later assessment, which is your summative assessment. So we really want you to do really as well as you can do, but you can do as well if you're guided and you know what you can do right and what you're not doing as well as you might do. Another question I get is, what is the typical kind of population of the year? What's the typical cohort? So we launched the course in 2018. We took on 18 students. Last year we took on 33 students. So in 2020 we kind of expect that we'll have about 40 students. This isn't directly limited, but there is a lot of competition for our course. So we're looking to grow slightly. So certainly in 2021 we'll be looking to get a little bit larger cohort. We are developing. We don't want to explode into 100 or 200 students overnight. We want that close connection with the students. So I want the students to kind of come past, feel that they can pop in, and I'll know them personally. And I think that's quite important for me as a director of the course to do. So one final question that I always get asked, I really want to make this really clear, that the modules are taught. So we might have 40 students in a year, but they're taught in individual pathways by experts in their field. So in their core skills in year one, there'll be 40 of them in the classroom, but when they do their chemistry, there'll be 100 or so in that class. When they do their materials or biosciences or geography, again, they're into larger groups. So a natural sciences student has a benefit of growing their network in the individual classes that they have, but we pull that all together, so we have a natural sciences cohort together. So we don't run lectures just for natural sciences from different areas. We put them into the classroom with other students, so they're taught by experts alongside other students in that class and assessed at the same level. So we do set quite a high bar for our natural sciences students because we think that's really important. So as soon as a student lands with us, we give them support in any which way that we can. So as course director, I take overall responsibility for the students. They can come to me directly, ask me about the course, but we also give them a personal tutor, which is an academic member of staff. They might want to go and ask all the questions to their personal tutor that they might not want to come directly to me, maybe about the course, maybe about other things. The personal tutor is there really as kind of a first point of academic contact. So if they want to some help with their CV, or they want to know where to ask all the questions, or they want to apply for a part-time job and they want to do a little bit of a chat about how to balance their time, or any other problem, whether it's academic or non-academic, the girlfriend, boyfriend problems, family issues and so on. Over the years we've seen it all, but we are there for the students as a kind of a point of contact, and we do really kind of push them to come to us with queries, questions, and we do, as I say, we do have the students kind of coming past, dipping in and saying hi, and that's really nice to hear how they've done in exams, how they're going in different modules, and really getting that kind of personal feel to the course. Now there are some students that would probably prefer to ask questions of other students, so we also give them a student peer mentor, and that's from the induction day and day one as well. So that's really quite important that they have that kind of bond and they know what's kind of coming in the later years. So that peer mentor is really quite important, we found. And there are an awful lot of other different kind of support mechanisms there. So we have kind of the school support offices, we have module organisers, lecturers, we have a director of studies within the natural sciences, within chemistry and so on. We have healthcare services, we have a dedicated careers and placement team. So if students are thinking that they might want to go on a placement or they want to help with their CV, they might well come to me as a personal tutor or course director and say, can I have a look at their CV? And certainly I will have a look, but I will also direct them to the people that are really experts in this area. So hopefully you can see, and this isn't an exhaustive list, but this gives you an idea of the kind of the breadth of the support that we can offer. So the benefits of natural science, it's really what I'm trying to do with this course is to really try and train people to not just think in terms of the individual disciplines, but really get them to think multidisciplinary, so allow them to communicate across the different disciplines in which they're working with. So again, coming back to if they're doing chemistry and physics, those two disciplines are very different, so the language barrier can sometimes be quite difficult. So a student that's worked in both those fields might feel able to communicate better, and so communication is a real big thing within the course, and also you'll see that's a transferable skill that they can use for their kind of further career. It does keep options open, So studying at A level or equivalent, students might find that they're really enjoying physics, they're really enjoying biology, they're really enjoying chemistry, and they're not really sure which one they want to follow at university. So the natural sciences course does kind of keep options open a little bit longer. And if they come to university, and as I said earlier, give the example of the chemistry and biosciences in year 1, they might find that by year 3 they really want to focus on the biology. So that allows them to keep the options open until a point where they might feel, actually, this is what I want to do. And again, coming back to the projects, that's something that you can really kind of build on. So the transferable skills are really integrated into our course. The time management, problem solving is absolute must, and this communication, which I've kind of been popping on about. So where next? Where do natural sciences students go? And this is a question that I'll use a slide here to try and get across. So even if you're a chemist doing a chemistry degree, it doesn't mean that you're going to be in a wet lab for the rest of your career. You might do quite a breadth of different areas. So natural science is even more diverse. It really is down to what you want to do, where you want to take it. So you might want to go into some interdisciplinary research, and again, that is really kind of pressing in these times. So that might be academic, or it might be in an industry setting. It might be that you want to go into the communication of science, either in publishing or as a science communicator, science writer, a medical writer, for instance. It might be that you want to go into further study, into teaching, into research, into postgraduate medicine as an entry there. It might be that you want to go into management roles. So a lot of our students have gone into management, sales, finance, into patent law, for instance, is also somewhere where our students have gone. So the last one here is government, and sometimes I get some quizzical looks from parents. But if you think about how the government kind of divides up the funds that they have, and they decide, well, actually this year we're going to cut funding to Alzheimer's research and increase funding to support more cars on the roads, the automotive industry. Where does that decision come from? So they're advised by the scientific advisory board, and this is somewhere where students can go in with a multidisciplinary aspect and understand different aspects much better at a deeper level, because they've worked in those different areas. So not only can they read and write to communicate across those different areas, but they actually have a better understanding of both those situations. So they might sit on research prioritisation boards, or they might be government advisors, consultancy, or get involved in kind of current policy development. So there's quite a breadth there, and it really does take a student to go through the pathway and figure out actually where it is they might want to go. And that's why placements are, again, come back to that opportunity. Students can opt in or opt out for placement, because that gives them an idea of where they might want to go, or experience different things. And certainly, if a student has no clue where they might want to go, we can put them in touch with the careers team, or students that have come back from placement. So we do a careers fair to allow that pollination of ideas. So I'll kind of come to an end with this last slide. And again, you're now looking at Loughborough because you've seen us, you've heard us about us in the news. And we're very proud of lots of things at Loughborough, but certainly our employability, our rankings within the university guides, in the league tables, and our our student experience. So the students like being with us. Staff are known for expertise in their teaching and research, which supports the teaching. We're known for a great campus, the great family feel, the vibe on campus is excellent. So I'll leave you with that, but what I'll say now is don't let this be the end of the conversation. Keep on talking to us. If you have any questions, please do get in touch. So the email address is here for you to email us directly, and do ask questions should you have any, and we'll be keen to address that. Okay, thank you. Bye bye.